So I'd like to welcome everybody to the Comfort Heating Systems webinar. We will be going through an hour learning about comfort heating systems, how to improve your system, how to save money, and how to save energy. Before we start though, a few logistics. We have a chat pod where you can ask questions throughout the webinar. However, I have a planned Q&A after the presentation and we'll look at those questions then. So if you do want to save your questions for until that time, that is also fine. For our trivia question on average, how much does comfort heating costs make up on your energy bill? The answer is, according to the DOE, Department of Energy, heating costs account for 42% of your energy bill, which is nearly half of your total costs. And that is why we are making a point to discuss comfort heating systems today. So I am Alana Colvin. I am an Energy and Environment Technical Advisor for PennTap. I work out of the Pittsburgh area and I perform energy audits, I support grant applications, and I work on community economic development projects throughout the counties. There is more information about me on the PennTap website if you wish to learn more about myself. Today's agenda. Today I'm looking to go over ways for you to save money on your building's heating costs. First, I would like to make sure we all understand the type of equipment that we're going to be looking at and understand the different types of fuels available. Then I'd like to discuss the common weaknesses and strategies for improvement of this equipment. Then I'm going to quickly review a few funding options to help upgrade old equipment and conclude with some PennTap services. So there are two ways to look at heating. We have comfort heating and process heating. Comfort heating is designed to make people feel comfortable where they work. For example, an office building generally only has comfort heating. With comfort heating, the outdoor weather has a significant impact on the amount of fuel you use. During the summer months, you might have no heating, but in the winter months, when the weather goes to zero, you will have an increase in fuel costs. Process heating occurs when there's heat used in a manufacturing process, such as an oven baking bread. The weather can also impact your process heating. If you consider a manufacturer who heats up metal, in the wintertime, they might have to heat it up for a longer period to get to a temperature versus that in the summertime. The easiest way to tell whether you have process heating occurring or not is to look at the summer months in your bills. If a significant amount of energy is being used for a process, then the summer will have a significant usage. If the summer month has very little usage, then you might just only have a hot water tank attached to that fuel type, and then you only have comfort heating occurring in the wintertime. In this webinar, we are strictly looking at comfort heating. There are several different types of equipment available to use for comfort heating. There are furnaces, boilers, heat pumps, forced air systems, radiant heating, and baseboard heating. What I'd like to take away from this information is the life expectancy and efficiency ratings of the different equipment. Overall, heating equipment is designed to last for an average of 20 years. The life expectancy will be impacted by how often the equipment is serviced, your location of the equipment, such as if the equipment is outside and exposed to elements, this will wear on your equipment. If the location is damp or dirty, this will also play a major role, such as rust buildup and other issues that will impact the life expectancy and efficiency of your equipment. The nameplate on your equipment and your specification sheets of your equipment will have information associated with the efficiency of your model. There are a few different ways to communicate the efficiency of your equipment. If the efficiency is not listed on the nameplate, then you can divide the heating output by the heating input for a percent value. You may also see the following on your equipment. You may see the annual fuel utilization efficiency, or AFUE rating. And this is how efficient the appliance is at converting the fuel into energy to heat your home. You may also see the Heating Seasonal Performance Factor, or HSPF. This is a specific heat pump rating. Other ratings that you might see on your equipment include Seasonal Energy Efficiency Ratio, or SEER, S-E-E-R, and the Energy Efficiency Ratio, or EER. These ratings would be found on HVAC equipment, but are in reference to air conditioning and not so much your heating side, so just for your reference. Your equipment may be ENERGY STAR rated, so if so, there will be an ENERGY STAR label on your equipment or on your specification sheet. So what is an ENERGY STAR piece of equipment? What does ENERGY STAR mean? ENERGY STAR is a trusted government-backed symbol for energy efficiency, which helps us save money and protect the environment through energy efficient products and practices. The label was established to easily communicate which pieces of equipment have been designed to reduce greenhouse gas emissions and other pollutants caused by inefficient use of energy. Products can earn ENERGY STAR labels by meeting the energy efficiency requirements set forth by the ENERGY STAR product specifications. EPA establishes these specifications. An important note, if you buy a heat pump or have bundled HVAC equipment, heating and cooling equipment, note that the equipment bundled together, the heating and cooling elements, must all meet the ENERGY STAR ratings in order to have the ENERGY STAR label. It's important to review your equipment to understand the limitations and to note that even if your equipment does not carry the ENERGY STAR label, maybe some of the elements meet the energy efficiency standards of ENERGY STAR. So you can look at the heating side of your HVAC to understand if it's truly considered ENERGY STAR rated or not. And same thing for your air conditioning. There are several different fuels you can use to heat a space. We are only going to look at the following: natural gas, coal, oil, propane, and electricity. Due to the differences in these fuels are charged in different units, such as cost per kilowatt hour for electricity, or per gallon, or per ton. Natural gas is just as often recorded in MCF or CCF, just as much as you will see it in therms. In this table, we have two costs listed, and I would like to highlight those. We have costs in common units, and we have costs in MMBTU. These costs in the common units are what you should be recognized, what you should be used to seeing. Electricity at 8 cents per kilowatt hour, propane around $2 per gallon. Oil, I have seen oil go up to $4, but in this example, we used $2.50. What this shows us is what the costs are per common unit. This is not an easy comparison to understand which fuel type is the best to burn, the most affordable to burn. So to convert that, we look at the British Thermal Unit, or BTU. A BTU is a basic unit for heat. That is why we have this over here. And you can see that although electricity is 8 cents per kilowatt hour, it is actually $23.40 per MMBTU to burn electricity for 1 hour. And natural gas comes to $4, coal comes to $4, oil is 18, and propane is 21, nearly $22 to burn. This is your apples to apples comparison. Note that although coal is a fairly inexpensive heating source, there may be significant costs associated with it. For example, you may have to pay an employee to operate a boiler all day to make sure that the fire is constantly going in the wintertime and that the fire does not go out. This labor cost can add tens of thousands of dollars, and in many cases will make other fuels, which although expensive, cheaper in the long run. Understanding your fuel options will help you understand how you can possibly save more money if you have the opportunity to convert your equipment or to upgrade to a different fuel type. So next, I'm going to go through a couple different pain points or issues recognized by the equipment we've discussed. Consider this an opportunity to walk down your equipment, to understand your setup and your settings, and also to make observations of your equipment. You do not need to solve any issues at this time. We're just making a list. Thermostats. Where are your thermostats located? How many thermostats do you have in your facility? Do you know what your thermostat settings are? Make sure that they're not close to a heat source or behind something that would impede their ability to sense the room temperature, such as a curtain. Thermostats need to be located on an interior wall, not an exterior wall, and also not in direct sunlight. In this picture, we can see that the thermostat is not only next to a window, which would be cold in the winter time, it is next to a heat source and is immediately above a computer, which would also be exhausting heat. In addition to all of that, it is on an exterior wall. This room has very limited opportunity to be as comfortable as expected when using that thermostat. These are things to keep in mind as you consider installing new equipment or upgrading new equipment, or just understanding how efficient your equipment can be in the setting that it is. Maintenance. Lack of maintenance or the refinement of maintenance on your equipment will have an impact on its performance. You want to check at the start of the season and at the end of the season to put things back how you found them. In this picture, this is an AC and an HVAC unit. The panels have been removed so that you can see the coils. In this case, the coils are frozen. However, no matter what it is that you're looking at, if you're looking at the AC side and that's impacting your HVAC equipment for the winter time, you need to make sure that you put your panels back on so that you don't have debris or pests moving in, so that your coils stay clean. Things you want to keep an eye on are whether or not your equipment sounds good. What is a good day versus a bad day? Like your car, you'll need to know when you get things checked out. Oil leaks or drips, and the coil condition. Are the fins dirty? If the fins are dirty, this will lower your efficiency output. Filters. So on the note of maintenance, you want to make sure you understand what type of filters you are using. What are their ratings? Depending on your ratings, you may need to check these filters more often. If they're able to block a lot of different size molecules, then you'll need to change out these filters regularly. Think about where your intakes are. What type of air are they sucking in? Are they sucking in low to the ground? Therefore, they could be sucking in pollen. If they're near mulch, they could be sucking in dirt. Are they near a parking lot where they're sucking in exhaust? Are they up high? What is around, like a tree? Is there pollen in that? What is around the intakes that are feeding your air for your fuel system? Dirty filters will stress the efficiency of your equipment. So just something to keep in mind. Equipment components. So as mentioned, HVAC is made up of multiple components. A furnace is only a heating unit, but you might have other systems in play. So a caveat, if you are not an expert on equipment, please don't touch things that would be considered unsafe, such as electrical wiring. However, just want to bring up, poor wiring can influence your equipment. It can break it down, it can cause fires, and or things can become loose. In that picture, wires are not only alligator clipped and taped together, which is never recommended, but they are also different sizes. These are things that will definitely cause hazards down the line. In the middle picture, we have a disconnected dampener. So therefore, the airflow will not be as expected, and this will cause issues with your heating elements. Missing or loose hardware, your equipment will vibrate, and as it vibrates, screws will become loose, belts will start to degrade, and you will have a lot of debris surrounding that equipment. If you see a lot of debris, you need to have it serviced to understand what it is that is falling apart. You shouldn't see debris. Insulation. You may need to determine if you are properly insulated in order to reduce your heating losses. As you can see in the lower right corner, we used an infrared camera to see the heat loss from an interior door being used as an exterior door, and therefore that door has a lack of insulation. We know that the heat is being transferred through the door because the bricks on the outside are cold. Note for all three of these pictures, hot and cold are determined by the infrared camera, and in this case, all three pictures refer to red as being near 80 degrees Fahrenheit, and the blue-black as referring to 39 degrees Fahrenheit. We can see the cool air from the outside is leaking into a room from an exposed vent fan. And in the top photo, you can see that the corner of the room is missing insulation or has damaged insulation. You would need to investigate further to find the root cause, but you did discover an issue and therefore know you can correct it. Boilers. Common signs for energy waste associated specifically with boilers. You could have leaks of steam or hot water in your system, loose or missing pieces of insulation along your piping. Your steam pressure might be too high. You could have malfunctioning steam traps, which is a very common issue, or a high stack temperature. Taking in any of these will help you make your system more efficient in the long run and have savings, cash savings. Strategies for improvement. So now that you've kind of walked down all of your equipment that could be improved, it's worth coming up with a checklist for implementing actions. Over the next few slides, we'll consider different actions you can take to improve your equipment and see those cost savings. A common opportunity that has immediate improvement includes reviewing the heating system schedules. In this chart, it was a natural gas boiler that was reviewed. We note that there is a hot water tank attached to the natural gas, and that is why we see some natural gas in the summer months. But it was asked of the client if we needed to turn on the boiler when they did. At their facility, they had a heat pump and extra Reznor heaters throughout the facility as supplemental heating. It was suggested that if they could hold off and start the boiler maybe in mid-November and then turn the boiler off in mid-March, the facility could save up to $2,600 per year in natural gas consumption. Since there are limited preparations in making this change, this would be an immediate savings for the year. In addition to this, there were broken regulators on the radiators. Make sure to double check your subsystems for operability. If the radiators are not functioning properly, the boiler will drop in its efficiency. And as an alternative, it was also discussed to add an integrated boiler control system. This is not a low-cost addition. However, it would provide flexibility to regulate the boiler. I wanted just to have one caveat about set points is to make sure you understand your equipment. What is your equipment rated for temperature-wise? I have a personal experience where in my home in southwestern Pennsylvania, it can get below 0 here. I had my setback set too low for overnight, and my furnace wasn't able to successfully kick back on due to the top part of my flue cooling down beyond what my furnace could keep up with. This created a pressure difference within my flue, and my furnace would trigger a safety shutdown because the fumes from my fuel were settling low by my CO sensors. So if you know you have a very cold night coming up, make sure to use setbacks that make sense for your furnace to be efficient and keep up with what you want, which is not a house at 40 degrees. All right, weather stripping. So weather stripping provides immediate positive impact as well. You can see this on your heating bills almost instantly. In this table, we have provided values associating with heating a facility and preventing heat loss due to the lack of weather stripping. In order to estimate these savings, we looked at the number of heating degree days necessary for the season. We looked at the cost of the heat. We looked at maintaining what it took to maintain the facility at 70 degrees inside. And we also considered a wind speed of 4 miles per hour. This is for drafts. 4 miles per hour is considered enough wind for you to feel it, such as blowing of a leaf or moving of your hair. So in this table, we can see that the weather stripping on a single door will save $148 per year. A garage door has savings of $267 per year, and caulking around a window can save you about $22 a year. This is all for one door, one garage door, and one window. In all of these paybacks, the payback period is nearly immediate, and based on how inexpensive weather stripping is compared to the cost of your fuel. So now consider how many exterior doors, garage doors, and windows your facility has. If you had 4 doors, you would save nearly $600. If you had 2 garage doors, you would save over $500. And 20 windows would be $440 per year in savings. This would come to over $1,500 in savings recognized per year. Insulating pipes. I've had the opportunity to review a boiler steam pipes throughout a facility, and on this slide, we see the pipes in the boiler room. We have insulated and uninsulated pipes. Then we see exposed pipes in a room on a first floor. This is the lower 2 pictures. We have insulated and uninsulated pipes. For reference, in the lower right image, we can see the Resner heater working in the background. From these images, we can see that the exposed uninsulated piping is nearly 200 degrees Fahrenheit, and the piping that is insulated, covered with the white insulation, is normalized to the conditions of the room. There were several examples of exposed piping within this facility. If this facility were to insulate these pipes, it is estimated they could save $1,400 per year. Pipe insulation is a low-cost opportunity, and for this facility, it would have a payback of 6 months. Also know that the pipes are hot and very dangerous for people to accidentally touch. These are all within the realm of someone leaning against. So just keep in mind that this type of heat, not only dangerous for a person, but will degrade your building. So as it lays in between the walls and has no insulation around it, it will definitely degrade the concrete walls or insulation that you have around it. Keep in mind. Roofs. As heat rises, your last defense is your roof. Is your roof properly insulated? The DOE recommends that if you have insulation rating of R30, you should add more insulation. And the EPA suggests you can save 11% on your energy costs associated with heating for proper insulation. Things to consider: is your roof clean? Do you have debris or standing water on your roof? This will degrade your properties of your roof. Standing water can cause mold, leaks, and wet insulation. We can see an example of wet insulation in those thermal images. On the left side, we can see that white patch that was done. They told me it was fixed. Well, with the thermal camera, we can see that there is still water leaking and that the patch did not cure the water leak. So if you do have standing water, it is something to keep an eye on and try to look into the pitch of your roof or the feeds of the water down to the ground. Curtains and fans. They come in many varieties. About 30% of comfort heating is lost through windows. Granted, the lure of the outside will be lost, but if you install tight cellular shades, this will reduce heat loss and provide up to 20% in energy-related savings to heating. If you don't have tight cellular shades at hand, using drapes that reach the floor can save up to 10% in heating costs. The thermal images show a curtain mitigating the heat loss between a heated room and an unheated room. In an industrial space, you can use plastic curtains that are made to help separate different zones and prevent heat loss or heat gain depending on your requirements. You could use an air curtain as seen in the lower right-hand side, which blows a wall of air when an exterior door is opened. You may notice this when you walk into a food store, you get that gust of air that greets you when you walk into the place. The Pacific Northwest National Laboratory has calculated the average energy savings from an air curtain for a commercial building to be about 4%. To take advantage of these savings, you need to use the air curtain during the wintertime, the summertime, and on windy days. Lofty ceilings in offices or warehouses can be troublesome to maintain comfortable heat. Using a high volume, low velocity fan can help your facility push hot air that has risen to the ceiling back down to the ground. A brewery installed an HVLS fan in their facility and were able to recognize over $1,500 in fuel cost savings for the winter months. Boilers. Specifically for boilers, if you can evaluate the following, could provide you with additional comfort heat savings. So is the boiler operating at its highest efficiency range? Does it need to be serviced? Did you reduce the steam pressure? This would increase its efficiency. Measure the flue gases to make sure that the ratio of air to fuel is correct. A boiler tune-up would correct this. Also installing economizers to preheat the feed water. So this way the boiler is not doing all of the work to heat that water. It will save you money on your fuel bill. Waste heat recovery. In addition to reviewing your primary sources of comfort heat, you can use supplemental heat through waste heat recovery within your facility. Waste heat is a result of various facility equipment outputs, from which, but not limited to, annealing furnaces. You could have server rooms producing heat, air compressor rooms produce heat. Recovering this heat can supplement your comfort heating and thus support cost savings, as well as reduce environmental impact. This can be for any size facility to take advantage of. I was able to walk through a small business who were able to recover the heat generated from their server room to use as supplemental heat within their building. This allowed them to turn on their primary heat much later in the year and then turn it off much sooner in the year. The server room was located in the basement, and through an exhaust fan, the heat was pushed from the basement into the office area. This practice allowed the small business to reduce their heating costs by 38%. Over the next few slides, I'm going to go over and highlight just a few programs available to help you upgrade your equipment. There are more programs discussed in our Funding for Energy and Efficiency Equipment Upgrades webinar, which was put on this July. We have all of these webinars recorded, and this webinar can be found under our events page under recorded webinars. But for now, we'll just go over a few. For Pennsylvania-based small businesses with 100 employees or fewer, you can use the Small Business Advantage Grant. This grant allows a business to approach an energy project or a pollution prevention project and install equipment with support of this grant. In order to use this grant, you must save $500 on your annual utility, and you must save 25% of your annual energy usage. There is $1 million available in this grant. It is a 50-50 eligibility requirements at the expense of the equipment. The grant amount will depend on your project, and applications are available through the Commonwealth's online application system. Grants are awarded on a first come, first served basis. PennTap is available to help you with these grants if you have a project in mind that you would like to look at. For those interested, you can go to www.deppa.gov and search for Small Business Advantage Grant or Google Small Business Advantage Grant Pennsylvania. You will have the opportunity to look at the grant guidelines, the link for the application, and there's also instructional videos on how to apply. If you have any questions, please feel free to reach out. Here's an opportunity through the Department of the Community of Economic Development, also known as DCED. They're offering the Pipeline Investment Program, which they call PIPE. The PIPE program provides grants to construct the last few miles of natural gas distribution lines to business parks and existing manufacturing and industrial enterprises. The intent of this program is to create new jobs in Pennsylvania while providing access to natural gas for residents as well. These funds may be used for the acquisition, construction, and site preparation costs associated with extending a natural gas pipeline to serve those eligible applicants. So if you're interested on who is considered an eligible applicant, you can log in to DCED. The website is provided below on the slide, and see what it is that you need to look for. Also contacting Brian at 717-720-1400. He will be able to answer any questions on this type of program. There is also a federal fund known as the USDA, United States Department of Agriculture, Rural Energy for America program, REAP. The REAP program provides guaranteed loan financing and grant funding for agricultural producers and small rural businesses for renewable energy systems or to make energy efficiency improvements. Any agro producer with at least 50% gross income coming from agricultural operations and small businesses are eligible in rural areas. Rural areas can be evaluated through the REAP website. REAP funds can be used for renewable energy systems such as biomass, biodiesel, ethanol, and solid fuels, geothermal for generation or direct use. They may also be used for high efficiency heating, ventilation, air conditioning systems, HVAC systems, doors, and windows, just to keep that in mind. Amanda Hope can be reached through her email or phone number if you have more questions. PennTap can also help you with these applications if you have any questions. Additional funding sources, I wanted to talk about CPACE. The Commercial Property Assessment Clean Energy, CPACE, was enabled in Pennsylvania in the summer of 2018 through Act 30. CPACE can be used for existing and new construction of commercial, agricultural, industrial, and nonprofit properties. Improvement projects can be for energy efficiency, renewables, and water conservation. Individual property owners voluntarily sign up to use CPACE and work with a private capital provider developing specific repayment terms. The CPACE lien transfers upon sale with the building. This is not attached to the person, and the loan does not accelerate. Some of the projects you can consider with CPACE include renewable energy improvements, water conservation measures, HVAC upgrades, boilers, heat pumps, geothermal, and building envelope improvements, among other improvements. So far, 10 counties have passed CPACE resolutions, and those counties include Allegheny, Bedford, Chester, Lawrence, Lebanon, Lehigh, Montgomery, Northampton, Philadelphia, and Wayne County. You should reach out to your county to see if CPACE is moving along in yours. If I didn't list it, there are movements to make CPACE happen across Pennsylvania, but at this time, those are the counties who have adopted this program. So, if you want to see a way to track funding throughout Pennsylvania, I would recommend using the Desire website. Desire, spelled D-S-I-R-E, is a comprehensive source of information on incentives that support renewables and energy efficiency in the United States. You can go to this website, click on Pennsylvania, and see all the different programs listed for that current time. And if you check it quarterly, you can see new programs as they pop up. That's what I would recommend. So thank you for participating with Comfort Heating as a whole and sticking with me through all of this. I do want to talk about PennTap now and some of our services that we provide. We are a statewide technical assistance organization charged with supporting Pennsylvania businesses and anchor institutions, including manufacturers, municipalities, educational institutions, entrepreneurs, and economic development agencies. We began over 50 years ago as one of the first technical assistance programs in the country. You can find us at pentap.psu.edu. PennTap has a diverse staff with backgrounds in chemical engineering, electrical engineering, and environmental science. Our staff includes certified energy managers, registered environment managers, certified energy auditors, and a Six Sigma Green Belt. We work closely with our clients to understand their needs and make appropriate matches to resources within the university and across the state with our statewide resource partners. PennTap has two pillars. We work under the energy environment and innovation. The technical advisors for energy and environment perform building retuning, which offers building operations, low cost, no cost method to improving your energy waste. Pollution prevention and energy efficiency assessments, also known as P2E2 assessments, where we help you decrease pollution and increase energy efficiency at your site. E3 assessments on buildings, which includes an E2 assessment, but also incorporating lean manufacturing into the process. And then we have the Energy Management System, or ENMS, which will provide your company with a framework to integrate energy efficiency into your existing management processes. We offer opportunities to Penn State students in the College of Engineering to gain real-world experience by having them assist with energy audits. And again, we go beyond energy as we work closely with our clients to understand their needs as we match them to additional resources within the university and across the state. The innovation side of PennTap provides technical and entrepreneurial assistance directly to companies. They connect companies with faculty, students, laboratories, and Penn State infrastructure throughout the state, and using the EDA University Center and Engagement, as well as other resource partners located. Innovation also brings companies to Penn State's Learning Factory. Any company sponsoring a project at Learning Factory is assigned a team up to 5 Penn State students from various engineering backgrounds to work on your project. Previous sponsors include GM, Boeing, Shell, FedEx, just to name a few. At the Learning Factory, we have many sponsors that are small to medium enterprises as well. Past Learning Factory projects have included everything from developing lightweight surgical vests to 3D printing for replacing obsolete parts. Innovation helps student entrepreneurs with the first steps in their pitch and business ideas and procuring funding as well. In 2019, PennTap helped 125 companies in 42 counties throughout Pennsylvania to save a total of $4.5 million. 38 projects were completed through the Learning Factory due to connections made by PennTap. Before we conclude, I'd like to tell you about an upcoming webinar. I'd like to announce that on October 21st, the Southwestern Pennsylvania Energy Efficiency Roundtable will be hosting a community resources webinar for your facility project and upgrades from 11 to 12. The Southwestern PA Energy Efficiency Roundtable's mission is to help businesses and industry in Southwest Pennsylvania reduce energy costs through improved energy management, energy efficiency optimization, and the implementation of cutting-edge technology. The roundtable provides a forum for large industrial and commercial energy users to share information and learn from experience of others based on various energy topics, from energy efficiency technologies to management strategies. During this webinar, industry experts will be sharing innovative and sustainable opportunities to improve production, quality, and efficiency of your facility across the state. The webinar will showcase regional resources available to support facility energy conservation and continuous improvement projects. And be sure to check out our energy toolkits on our website. These toolkits are free to use and are filled with resources to help you estimate your potential energy savings from your projects for your home or facility. The toolkits are divided into 4 sectors: commercial, manufacturing, residential, and schools municipalities. The tools provide the user with energy cost calculators, fact sheets, and supplemental resources. Once you're done, you can always contact PennTap for a professional energy audit to narrow down where to begin on your next energy project. And with that, I have finished this webinar. If you have any questions at this time, please type them in the chat box and I will answer them to the best of my ability. I really appreciate it. If you have any, go at it. If not, we'll wait a moment here. And I do appreciate everybody hanging tight. Well, at this time, it doesn't look like there are any questions. If you do have a question, please feel free to email me. You can do this by contacting me through my email address, afc5057@psu.edu, or you can always give me a call. This is my cell phone number, 724-757-2702. If you have anything that comes to mind, I'd be willing to talk it through with you and seeing what PennTap can do for you. With that, I want to thank you, and I hope everyone has a fantastic day. Take care.